When we usually talk about systemic risks to the global economy, we tend to picture things we can sort of see coming, right?
Right, like in boardrooms or on trading floors.
Exactly. A central bank hinting at a surprise rate hike,
Right.
or a sudden, tectonic shift in a trade policy, a sovereign debt crisis. We look for human fingerprints on the steering wheel.
We want someone to blame.
We really do.
Mm.
But right now, there is a massive, multi-trillion-dollar economic engine revving up, and it's not happening on Wall Street. It's not in the central bank.
Yeah.
It is happening deep beneath the surface of the Pacific Ocean.
And it's an engine that operates entirely on fluid dynamics, thermodynamics, and atmospheric pressure. Yet its output over the next few years will literally be measured in lost global GDP, persistent inflation, and fractured supply chains.
Which is just, it's wild to think about. And the data coming in is pointing towards something absolutely massive. So we are so glad you were here with us today. Today is August 18th, 2026.
Hot off the presses.
Literally. The research and data collection we are unpacking today was finalized on this exact date, August 18, 2026. You are tuned in to Macroeconomy AI, and the title of today's deep dive is AI Observatory, August 8 through 15, 2026.
We have a lot of complex, highly consequential ground to cover today regarding the newly audited technical report on the 2026 El Niño cycle.
We really do. And I want to genuinely thank you for tuning in and giving us your time today. But before we jump in, a quick word from our sponsor. Today's deep dive is brought to you by Global Data Tech Analytics.
A great tool for this kind of macroeconomic analysis.
Totally. As you know, our channel's mission is bringing a compilation of analyses and news on macroeconomics, technology, and artificial intelligence. With Global Data Tech Analytics, you get the enterprise-grade tools you need to make sense of all those shifting global trends. Check out the link in our description to learn more.
So our mission today is to take this technical report on the 2026 El Niño cycle and really translate that ocean physics into hard macroeconomic realities.
Right, looking at the localized scenarios and the systemic risks. Because, before we can even touch the economic fallout, we have to grasp the sheer physical scale of the anomaly currently unfolding.
Yeah, to understand the economics, you really must first understand the mechanism. So we all know the standard ENSO cycle, the trade winds blow east to west.
Right. Pushing the warm surface water toward Indonesia.
Exactly. And that allows the cold water to well up off the coast of South America. But right now, those winds are failing. We are seeing bursts of westerly winds, and that warm water piled up in the western Pacific is sloshing eastward.
In what we call downwelling Kelvin waves, right?
And as this heat moves east, it pushes down the thermocline, that's the boundary between the warm surface water and the cold, deep water. That physically suppresses the upwelling of cold water off Peru and Ecuador.
So the surface of the eastern Pacific just starts baking.
It bakes. And that sets off a highly disruptive chain reaction known as the Berkney's feedback loop.
Wait, a feedback loop, so it's like a microphone and a speaker.
That is a perfect way to look at it.
Like if the ocean is the speaker and the atmospheric wind is the microphone, the ocean warms up, which alters the pressure and weakens the wind.
Right.
And then that weakened wind feeds back into the ocean, allowing it to get even warmer, which physically forces the winds to weaken even further. It just creates this deafening, compounding screech.
Exactly. The atmosphere and the ocean lock into a cycle that amplifies the anomaly at an alarming rate. And the data from August 2026 shows this loop operating at an extreme level.
How extreme are we talking?
Well, according to the NOAA Climate Prediction Center, the sea surface temperature anomaly in the Niño 1+2 region, right off the coast of South America, is currently sitting at plus 2.9 degrees Celsius above average.
Which is incredibly hot for that specific patch of water. But what's happening underneath seems even wilder.
The subsurface heat is the real story here. The models are tracking an extreme anomaly of plus 10.0 degrees Celsius down in the depths of the eastern Pacific.
Wow, 10 degrees.
Yeah, it is a massive latent reservoir of thermal energy just waiting to breach the surface. And because of this thermal battery, the official forecast gives a greater than 90% chance of a very strong El Niño event this fall and winter.
Over 90%.
Yes. And even more strikingly, they put a 69% probability on this becoming a historic event.
Okay, you're throwing around the word historic and talking about plus 10 degree subsurface anomalies. But, with a 69% probability, there's still nearly a 1 in 3 chance this just fizzles out entirely, right? Or at least peaks at a perfectly normal, manageable level.
I mean, the 31% chance of not hitting that historic threshold certainly exists, but it doesn't mean the threat evaporates. The climate system is incredibly noisy.
Right.
Phenomena like the Madden-Julian Oscillation or complex interactions with the Atlantic and Indian Oceans, they can modulate the final outcome. However, the physical reality of a plus 10 degrees subsurface anomaly doesn't just vanish.
The heat has to go somewhere.
Exactly. Even if the peak misses the absolute highest historical benchmark, a greater than 90% chance of a very strong event means massive global disruption is essentially already locked into the system.
But to even use the word historic, we need to know exactly how we are measuring history. And as of February 2026, the official measuring stick fundamentally changed.
It did, and that transition completely altered our understanding of the historical records. For decades, the gold standard was the ONI, the Oceanic Niño Index.
Okay.
It measured the rolling 3-month average of sea surface temperature anomalies in the Central Pacific against a 30-year historical average.
Yeah.
If it hit plus 0.5 degrees above that average for 5 overlapping periods, you had an official El Niño.
But the obvious flaw there is that the ocean itself isn't the same baseline temperature as it was 30 years ago.
Right, exactly. The global oceans are steadily warming due to climate change. So using the old ONI, an El Niño today looks artificially stronger simply because the background temperature of the entire ocean is higher. To fix this, in February 2026, NOAA officially transitioned to the Relative Oceanic Niño Index.
So RON isolates the actual El Niño effect by taking the temperature anomaly in the Pacific and subtracting the background warming of the global tropical oceans.
You got it.
It's kind of like trying to measure how loud someone is shouting on a moving train. The old index measured the total noise, the shout plus the rumble of the train. RNA subtracts the sound of the train, the baseline global warming, so we only hear the shout.
That is a great analogy. We get the pure intensity of the El Niño pulse itself. And stripping out that baseline global warming trend scrambles the historical rankings in a pretty revealing way.
How so?
Well, under the old ONI metric, the 2015 to 2016 El Niño was the undisputed record holder. It hit a peak of plus 2.6 degrees Celsius. But when we apply the new RNI standard and remove the background train noise, 1982 to 1983 actually takes the crown as the strongest pure El Niño on record, at plus 2.5 degrees Celsius.
Wait, really? So 1982 is actually a louder shout. It was just happening on a quieter train.
Precisely. And we saw the impact of this new metric recently, too. The 2023 to 2024 El Niño was considered bordering on very strong under the old index. But under the new RONI standard, it was downgraded to just a strong event, peaking at plus 1.5 degrees.
Which provides a much clearer picture of the cyclical volatility versus the structural warming trend.
Exactly.
But whether we are measuring the shout or the train, the economic reverberations of this heat are deafening. This shifting tropical heat physically alters the atmospheric jet stream, which completely rewrites global agricultural scenarios.
Yeah, we call these mechanisms teleconnections. When you move that much heat and convection around the equatorial Pacific, it disrupts the balance of the entire troposphere.
Okay.
It generates planetary-scale atmospheric waves known as Rossby waves.
Right. Imagine throwing a massive boulder into a fast-moving river. The ripples alter the flow downstream.
That's it exactly. These waves change where high and low pressure systems set up around the globe, accelerating and shifting the subtropical jet stream.
But a shifted jet stream doesn't just mean like a rainy day in Argentina. It fundamentally rewrites the math on global caloric output. If the rain moves south, what happens to the wheat?
Well, statistically, we see a very clear pattern of regional risks. The shifting air currents create massive, persistent, high-pressure blocking domes over certain regions.
Like invisible atmospheric mountains.
Exactly. They prevent moisture from arriving, resulting in a heavily increased likelihood of severe drought in Southeast Asia, Indonesia, and Australia. In South America, the Amazon basin and northeast Brazil also face severe drying and heat.
And on the flip side,
Conversely, the jet stream acts like a locked fire hose over other regions, bringing much higher risks of heavy flooding rains to southern Brazil, Uruguay, Argentina, and the southwestern United States.
let's get into the mechanics of how this hits the global supply chain. If we look at the drought zones, rice outputs dropping in India and Thailand don't just mean less rice on the shelf. The immediate mechanism is political.
Right, governments panic about domestic food security and trigger export restrictions.
We've seen that before, and it causes cascading price spikes in staple foods across the globe.
It does. And looking at Vietnam and Indonesia, the intense heat stress puts Robusta coffee and sugar yields at severe risk. In Australia, the winter wheat crop could face widespread failure. The high-pressure blocking systems literally starve the crops of the moisture they need during crucial development phases.
But South America is a wild macroeconomic variable here because it's a complete balancing act. I mean, you have Brazil, an absolute agricultural powerhouse. The drought conditions in the center west might decimate soy and corn crops, but the heavy rains in southern Brazil and Argentina might actually lead to bumper crops there.
It's true.
So if the north dries up and the south gets a bumper crop, doesn't global GDP just shrug and balance out?
Yeah.
Like, why isn't this a net zero impact for the global economy?
It is really tempting to look at a global spreadsheet and assume the gains perfectly offset the losses. But economic shocks don't net out, largely due to systemic supply chain friction and capital immobility.
What do you mean?
You can't magically teleport farming infrastructure, processing plants, specialized labor, or transport logistics from a drought-stricken region to a flooded region overnight.
The tractors and the grain silos are bolted to the ground where they are.
Exactly. An extreme bumper crop in the south doesn't help the farmer in the north who just defaulted on their loans, laid off their workers, and stopped buying fertilizer.
That makes sense.
And that default ripples into regional banks, tightening credit for everyone else. The fictional costs of moving capital, the localized bankruptcies, the stranded assets, and the extreme volatility in price discovery, all of that creates a massive deadweight loss for the broader economy. The supply chain is a highly optimized, fragile web, not a fluid pool of resources.
Which bridges the gap between localized farm failures and the trillion-dollar price tag. Because the friction in those supply chains leads directly to macro-level GDP impacts. Researchers can now quantify this destruction, and the numbers are just staggering.
They are. Historically, mega El Niños have destroyed immense amounts of global wealth. The report highlights two major macroeconomic models that quantify this drag.
Let's hear them.
A major 2023 study looked at the persistent effect on global economic growth. They estimate that the 1982 to 83 and 1997 to 98 events cost the global economy between $4.1 trillion and $5.7 trillion in lost growth over a 5-year window.
Up to $5.7 trillion. Unbelievable. And the other model?
The second major model from that same year uses a nonlinear climate economy model. They are a bit more conservative, estimating losses between $1.3 trillion and $3.9 trillion for those same historical events over a 4-year window.
Still massive.
Right. While the methodologies differ, both point to a massive, persistent destruction of value. The growth curve is bent downward, and it really struggles to recover.
Because this isn't just the cost of replacing a broken window in a factory, right? It's the invisible cost of all the products that a factory couldn't build while the window was being fixed, plus the lost wages of the workers, plus the stalled research and development because profits took a hit. It's the compounding loss of growth over time.
Exactly. The lost trajectory of growth is the true macroeconomic cost. And bring this right up to the present, a 2026 projection by the Peterson Institute for International Economics, the PIIE, estimates that the current event we are tracking could drag down the global economy by roughly $686 billion almost immediately.
And what does a $686 billion immediate drag look like to you, the average consumer? That translates into persistent structural inflation. It's higher food costs that force central banks to keep interest rates high, which squeezes everyday mortgages and chokes off small business loans.
It hurts everyone. And if policies don't adapt and we apply the compounding growth decay models, that initial drag could reach approximately $3.1 trillion in lost GDP over the next 5 years. What is particularly concerning is the distribution of these losses. The data shows this economic damage is disproportionately concentrated in low and middle income countries.
Ones that can least afford it.
Right. The nations with the least fiscal space to absorb the shock, and where a higher percentage of household income is spent on food rather than services, they bear the absolute brunt of it.
And knowing these massive modeled costs, the looming question for long-term economic forecasting is how climate change will warp this multi-trillion-dollar wrecking ball in the future.
Definitely. And we have to look closely at the scientific consensus, specifically the IPCC's 6th assessment report, the AR6. There is a critical nuance here that often gets lost in broader discussions.
Which is?
The IPCC states that there is actually no model consensus that the amplitude of El Niño's sea surface temperatures, the heat engine itself, is inherently increasing or decreasing due to global warming.
Wait, really? So climate change isn't necessarily making the actual ocean temperature anomaly of El Niño hotter?
Based on the current models, there is low confidence in any systematic change to the amplitude. The historical ROI data backs that up. However, there is high confidence that the rainfall variability and the extremes associated with El Niño will be far more severe in a warmer world.
So the engine of El Niño isn't necessarily getting bigger, but the payload of extreme weather it drops on us is getting much heavier.
That is exactly it. The underlying physics explaining why is the Clausius-Clapeyron relation. It is a foundational thermodynamic principle. A warmer atmosphere holds more moisture.
Right.
For every degree Celsius of warming, the atmosphere can hold about 7% more water vapor. When an El Niño shifts the atmospheric circulation and triggers a drought, the hotter baseline temperatures bake the soil faster, turning a dry spell into a severe agricultural crisis.
And when it triggers rainfall.
The saturated atmosphere dumps significantly more water, turning a normal storm system into a catastrophic flood.
The disruption becomes supercharged by the baseline warming, even if the pure ocean anomaly itself is a standard size. The mechanism of destruction just scales up. As we wrap up this deep dive, I want to leave you, our listener, with a final thought to ponder. We know this physical phenomenon systematically destroys trillions of dollars of wealth.
It does.
We know it disproportionately impacts developing nations, rippling through the global supply chain as sticky inflation and defaulted debt. And incredibly, we can predict it months in advance with over 90% certainty using subsurface ocean metrics. So how long until global financial systems, massive hedge funds, and sovereign wealth funds start proactively shorting or insuring against these specific ocean temperatures before the first drop of rain even falls?
I mean, the ability to price that risk in real time based on fluid dynamics thousands of miles away, it is going to fundamentally change how global markets operate.
It really feels like the ultimate macroeconomic leading indicator, literally floating in the Pacific Ocean. Now, before we sign off, I need to read our mandatory disclaimer. This content is strictly for informational and educational purposes, compiling public market data, projections, and analyses. The material does not express any ideological bias and does not constitute investment, financial, legal, or tax advice of any nature. Economic and technological projections are subject to frequent revisions in light of new market data and facts. Likewise, past yields do not guarantee future returns. The purpose of this space is to introduce concepts and stimulate academic and professional debate. Strategic, financial, or wealth decisions require in-depth and customized analysis. Therefore, always consult qualified professionals and specialists before making your decisions.
Thank you so much for joining us for this deep dive. We deeply appreciate your time and curiosity, and we invite you to join us for our next exploration.
That was today's Macroeconomy AI. We'll leave it here. You all stay well and keep an eye out for our new broadcasts. Subscribe to our channel, access the links, and follow Macroeconomy AI on social media.
Bye!